Suppose we have a quadratic function, something like ax squared plus bx plus c. In the preceding example, we saw how to find the minimum point on the graph of that quadratic function. How did we do that? We first completed the square, which was done like so. This was, if you remember, the general theory of completing the square. And then, how did we conclude in the preceding example that we actually had the lowest point on the graph of the quadratic? Well, let's think about it. We had an expression of the form a times x minus b over 2a squared. But what's important is that this expression here is a square. Right? So this expression here is a square. So I'm having a times a square minus d over 4a. Right? So that's the situation that I'm at. So I'm guaranteed that a square is always positive. So I'm guaranteed that if a is greater than 0, so I'm guaranteed that if a is greater than 0, this entire expression here is always positive. So I'm guaranteed that the graph of my function, the value of my function, can never drop below negative d over 4a. So once again, if this a here is greater than 0, then I'm guaranteed that the value of this, so this entire expression here is positive. So I'm guaranteed that the smallest that this quantity can be is when a times the square is actually equal to 0. If the square is actually equal to 0. If this, because the square cannot be negative, so the smallest it can get is 0. So the quantity that I have boxed here can never drop below negative d over 4a. Similarly, if my a here, my leading coefficient, is negative, then the square is still positive. Negative times positive is negative. So if my leading coefficient is negative, the value of my quadratic can never exceed negative d over 4a. Right? So if the leading coefficient a is negative, so if the leading coefficient here is negative, my quadratic can never attain a value larger than negative the discriminant over 4a. So let's summarize this observation into a mathematical statement. If the leading coefficient of my quadratic is positive, then my function, my quadratic, has no maximum, because it opens indefinitely, it grows infinitely large. So if the leading coefficient is positive, then my function has no maximum and has a minimum attained at the tip of the parabola, which is given when x is equal to negative b over 2a. If my leading coefficient a is negative, I have a parabola which opens down, and then that function has a maximum when x is negative b over 2a. In both of these cases, the actual extreme value, so the actual extreme value, so this height, the height of the extreme point, so this is the extreme value. So that's, in both of these cases, that's negative the discriminant over 4a. In this case, the extreme value is this distance here. So this distance, this vertical distance, is negative d over 4a, that distance.